Hello, my name is Ardi and we are going to solve problem 7.32 from Sadiku book. So the question is evaluate the following integrals. All of them is in singular function. So let's get started. So in problem A, okay, I will rewrite the problem first. So I will have integral from 1 to t of u lambda d lambda. Okay, probably that we need to think of is the definition of the u lambda. U lambda is actually a piecewise function here, so it will be 0 when lambda is less than or equal to 0 or less than 0, or 1 if lambda is greater than or equal to 0. Okay, and because the integration limit is 1 until t with the assumption of t is greater than 1, we just use this part here. So we can rewrite this integral here as integral from 1 to t of 1, because the value in this integration limit is 1 of u lambda, right? D lambda. Okay, and then we can integrate that. This is just lambda, so we will have lambda, and we can plug the integration limit into the lambda here. So let's plug t here, and then minus, let's plug 1 into lambda. So the answer is t minus 1 for problem A. Okay, always remember the definition of the function when integrating a singular function here. So now let's move on to problem B. So we will have integral from 0 to 4 of r t minus 1 dt. Okay, now let's remember that rt is a piecewise function here. So it will be 0 when t is less than or equal to 0. But that will be t when t is greater than or equal to 1. Okay, but we are not asked about rt, we are asked about integrating rt minus 1. So we can plug the rt minus 1 into this part here, and still this one will be 0, and this one, because we changed the t into t minus 1, this will be t minus 1 here. And then this will be t minus 1 is less than 0. And this one, t greater than 1, I mean t minus 1 is greater than or equal to 0. Okay. This is not 1, this is 0. Sorry about that. So we can move this minus 1 to the right hand side. So we will have t is less than 1, and this is t is greater than 1. So that is the logic of this function here. And now we can divide this into two cases, right? Which is between 0 to 1 of r t minus 1 dt, and then plus integral of 1 to 4 r t minus 1 dt. Okay, now let's plug the piecewise function here. So we will have integral from 0 to 1, and then this one will be 0 dt, and then plus integral 1 to 4 r t minus 1 dt. Okay, I think my slide is full. Let's clean up the board first. Okay, now let's do that. So this part is just integral of 0 t. We will have 0, and all of that will equal to 0, right? So we can just evaluate this function on the right here. So this will be integral from 1 to 4 rt minus 1. Remember that if t is greater than equal to 1, that will be t minus 1. So we'll have t minus 1 here dt. Okay, now let's integrate this. We can just use power rule. So we'll have 1/2 t squared and then minus t, and then the integration limit that will be 1 until 4. I mean integration bounds. I don't know the English. But then let's plug in this 4 first. So we will have 1/2 multiplied by 4 squared minus 4, and then minus 1/2 multiplied by 1 squared minus 1. Okay, I think we will have this 16. Okay, we will have 8 minus 4 minus, and this will be 1/2 minus 1. So I will have minus 1/2. Okay. And on this part, I will have 4 minus and minus becomes plus 1/2, or we will have 4.5. And this is the answer for problem B. Okay, now let's clean up the board before we continue. Okay, one more is the integral of that one, so let's rewrite that. So we'll have integral from 1 to 5 of t minus 6 squared direct delta function t minus 2 dt. Okay, and whenever we have direct delta function, this means that we plug this function at t is equal to 2 into the function that multiply it. So this will equal to t minus 6 squared at t is equal to 2, which is good because 2 is inside the integration bound here. Okay, so we will have t is equal to 2, so I'll have 2 minus 6 squared, and we will have minus 4 squared. Minus 4 squared, which is 16, because negative squared becomes positive, so I will have 16 here for the question C. And I think that's all for problem 7.32. Hopefully this will help you solve this problem. Thank you for watching. See you in the next video. Bye bye.